All right, Miss Teasley here. Today we're going to be solving exponential and logarithmic equations. We touched on solving exponential equations when we first started the unit. We're going to use something that I call Equate the Bases. So basically, this is the property. So if you have a base raised to the x power and it equals that same base raised to the y power, since it's an equation, that means x has to equal y. So that's what equating the bases. That's how we go about using the equating the bases. It's going to help us solve this. When we make our bases equal, that means the exponents will have to be equal. So when I look at a problem like example 1, it says solve. I'm going to have 3 raised to the 4x plus 1 power equals 81. My goal is to get x by itself. All right, so in order for me to get that x out of the exponent, when I solve this problem, I'm going to have to equate the bases. So on this left side, I have 3 raised to the 4x plus 1. When I get over here to the right side, I can rewrite 81 using the base 3. 3 raised to the 4th power equals 81. So I just rewrote 81 as 3 to the 4th power. So now, since both sides of the equation has a base of 3, that means that the exponents are equal to each other. And so once I get to this step, the only thing I need are the exponents. 4x plus 1 equals 4. So drop the base. And then, drop the base. Set exponents equal. And then solve. Let me see if I can move this out of the way. Center it a little bit. I got a feeling that's not going to work. Yeah. Move this down some. So I'll just write it here. So then solve for x. So those are So now that the bases are the same, I dropped off the base of 3, and now I'm only dealing with my exponents. 4x plus 1 equals 4. So to solve this for x, I'm going to subtract 1 from both sides. So 4x equals 3. And then to get x by itself, I'm going to divide both sides by 4. And that's your value for x. X equals 3 over 4. All right, same thing for example 2. I have an exponential equation. I'm going to equate the bases. So if you notice on the left side, I have a 4 and I have an 8 over here. Well, I can rewrite 4 and 8 using a base of 2. So on the left side, 4 squared is just 2 to the 2nd power. So I'll rewrite 4 as 2 squared, but you can't forget that you already have that 3x minus 1 there. Let me erase that. So that 3x minus 1 that's there, it has to stay there as an exponent. So in parentheses, you want to put that 3x minus 1 beside your 2 because you're going to multiply. Then on your right side, 8 can be written as 2 to the 3rd power. Again, you have an exponent already there, x plus 5. So I keep x plus 5 in parentheses, and it goes beside a 3. So make sure you put those parentheses. So now that my bases are the same, I have a 2 on both sides. The only thing I need now are my exponents. So in my first exponent, I have a 2, parentheses 3x minus 1, equals on the right side 3 as an exponent, and then x plus 5 is beside it. This is the equation that I'm going to solve to get my final answer. So from here, distributive property, 2 times 3x is 6x. 2 times negative 1 is negative 2 or minus 2. Then I distribute my 3 to the next parentheses. 3 times x is 3x. And 3 times positive 5 is positive 15. My goal is to get x by itself. So I'm going to subtract 3x from both sides. 6x minus 3x is 3x. Bring down that minus 2 right behind it. Bring down my equal sign. On the right side, I have that plus 15 or just positive 15 left. Again, my goal is to get x by itself. So I want to get rid of this minus 2 by adding 2 to both sides of the equation. That leaves me with 3x equals 17. And then you divide both sides by 3. So x equals 17 over 3. All right. So let's see. So now we're going to be looking at log equations. Well, sorry, not log equations. They're giving us the log properties. We're not going to be using this right now. We're still talking about exponential equations. We'll be using logarithms to help us solve this equation. All right, so the one-on-one property for logarithms, all right, they have here. So let's talk about how we go about doing this. So basically, if you look at this box, it says if x equals y, notice how when you get to what I circled, you still have the x and the y, but what's in front of both x and y is that log base b. All right, so you can put the log of a base in front of both sides of the equation. That's how it's going to help us solve this. So you look at example 3, I can't equate the base. All right, bases. There's no way I can take a 7 and 21 and rewrite those using the same base. So what we do is we use logarithms to help us solve this. So let me rewrite this. I have 7 to the x minus 3 equals, leave a little bit of space, 21. So I need to get x from out of the exponent. All right, I want that x to come down. Well, the only way I can get the x to come down is to put a log so that I can bring that x minus 3 in front of it. I'm going to use log base 7. All right, the reason I'm using log base 7 is because the 7 is the base of the exponent. All right, what you do to one side of the equation, you got to do to the other. So that becomes log base 7 in front of that 21. All right, here, this x minus 3, using my properties of logarithms, whenever you have an exponent, now that I have that word log there, I can bring that x minus 3 down in front, and I'm going to keep it together. So I'm going to put parentheses. And beside it, you have log base 7 of 7 equals log base 7 of 21. Well, log base 7 of 7 is just 1. 7 raised to the first power is 7. So x minus 3, that yellow stuff just becomes times 1. And really, to skip that step, so going back, I could use that inverse property. I have a 7 as a base for my log, and I have a 7 as an exponent base. So they cancel each other out, and I'm just left with x minus 3. So you can do it just in one step there. So x minus 3 equals log base 7 of 21. All right, that log base 7 of 21 is just some decimal you could put in your calculator. They want us to keep it in exact form. I'm going to actually do both. My goal is to get x by itself. So to get x by itself, I'm going to add 3 to both sides. So this is x equals, the 3 is separate from this log. You can't add 3 to the 21. That log base 7 of 21, I can even put a parentheses around it, stays that way. And then I have that plus 3 at the end. So this is the answer. If I wanted to get an equivalent decimal or approximation, I can put this in my calculator. So log base 7 of 21 plus 3. So let me open up my calculator. So miscellaneous log 7 of 21, that's that decimal, and I would just put that plus 3 behind it. So approximately 4.565. All right, that's the approximate answer. So whenever you can't equate the bases, you want to use logarithms to help you solve. right, so I cross that example out. Let's look at one like example 5. So here's another example, exponential equation. I can't equate the bases, but what I can do is I can introduce log on both sides of the equation. So we have, I'm going to write this down again so I can have more space. E to the 2x plus 5 equals, leave a little bit of space, 18. So I want to get that 2x plus 5 down. So what I do is I take the log and whatever base I have, which is e, I'm going to put log base e there. All right. What you do to one side of the equation, you got to do to the other. So this is log base e. Now recall, log base e of x is the same thing as just ln of x. On the left side, this e and this log stuff cancels out using the inverse property. And then I have 2x plus 5. Over here, log base e is just ln of 18. All right, so we'll write it as ln instead of log base e. My goal is to get x by itself. So to get x by itself, I'm going to subtract 5 from both sides. Now remember that 5 and 18, you can't combine those. So you would put a parentheses around that 18. So what you have is 2x equals natural log of 18. And you just stick that minus 5 right behind it. Your goal is to get x by itself. So I'm going to divide both sides by 2. Just draw one big old fraction bar. All right, divide by 2. And then this will be your final answer. Natural log of 18 minus 5 over 2. So that's minus 5. And then, of course, we can get the approximate answer by putting this into the calculator. So let's see, natural log of 18 minus 5 divided by 2. Oh, let me do that. So first of all, I need a fraction. So I'm going to hit the division button. Then I hit ln. What is it? Natural log of 18 minus 5. So 18, put a minus 5 behind it, and that whole fraction is divided by 2. So negative 1.055. So that is your approximate answer. All right. So now let's look at some log equations. So just like when I use logarithms to help me solve an exponential equation, I'm going to use exponential form to help me solve a log equation. So let me write that down. So to solve this, I'm trying to get x by itself. I'm going to rewrite in exponential form. So when I rewrite this in exponential form, the base of the logarithm is 3. So I'll write down 3. Logarithms equals the exponent. So the exponent is 2 in this case. So this is 2 squared equals, so remember 3 to the second power goes like in a circular motion, equals what's beside it, which is x plus 3. So you're trying to solve for x, and then once you simplify this, 3 squared is 9 equals x plus 3. To get x by itself, I'm going to subtract 3 from both sides. 9 minus 3 is 6, so x equals 6. Try number 8. All right, number 8 will be a great example where you can pause your video, try it, and come back. All right, so for number 8, we're still going to use rewrite it in exponential form. Remember, natural log is log base e. So I want to write that because I want to rewrite this in exponential form. So the base of the logarithm is e. So the base of my exponent is going to be e. So this is e to the 4th power equals this x plus 7. Remember E is just a number. You can use your calculator, once we want to get our final answer. I'm going to leave it as e to the 4th for now. My goal is to get x by itself. So I want to get rid of this plus 7. So I'm going to subtract 7 from both sides. So x equals e to the 4th minus 7. That's the exact answer. And I want to get the approximate answer. I can just put this into my calculator, right, and get the decimal approximation, e to the 4th minus 7. So functions, we in Desmos just hit the ABC button down here at the bottom. So e, raise it to the 4th, and then there's a minus 7. So that would be 47, 3 decimal places, 47.598. So 47.598. Approximate answer. All right, let's look at this log equation. Well, first of all, let's talk about the restrictions on logarithms. All right, when you're dealing with a logarithm, you can't take the log of 0 or a negative number. All right, so whatever's beside that log shouldn't be 0 or any negative number. So when it comes down to that, when we solve our log equations, we have to come back and check our answers to make sure that once I plug in the value for x, that I don't get a negative number in that parentheses, or I don't get 0. If you get a negative number or if you get 0, you have to exclude that x value as your answer. All right, so if you look at this example right here, this example has log written twice. I have a log base 2 of x minus 5 added to another log base 2 of x plus 2 equals 3. I can use exponential form to help me solve this, but before I do that, I need to condense this side. So condense, you want to condense and write it as one logarithm. So you remember properties of logarithms. When I have a plus, that becomes a product. So log base 2, x minus 5, and then it would be times x plus 2. So that's how you condense this side using properties of logarithms. And then that equals 3. So now I can solve this by rewriting the exponential form. All right, so to rewrite this in exponential form, the base is 2, so 2 to the 3rd power equals this stuff beside it, which is x minus 5 times x plus 2. All right, so simplifying this, I get 8 equals, using FOIL or the distributive property, x times x is x squared. X times positive 2 is positive 2x. Then I come back and distribute this negative 5. Negative 5 times x is negative 5x. Negative 5 times positive 2 is negative 10. All right, so I saw this x squared pops up, so I'm dealing with a quadratic equation now. So to solve this, I want to simplify this right side first. So 8 equals x squared minus 3x minus 10. Since I have a quadratic, I want to have the set equal to 0. So I want to subtract 8 so that I have 0 on this left side. 0 equals x squared minus 3x minus 18. And then here we go. To solve this, we're going to solve by factoring. So when I solve this by factoring, I have my 2 parentheses. The x squared breaks down into x times x. I'm looking for 2 numbers that multiply and give me negative 18. But when I add them together, I get a negative 3. So that would be a negative 6 times a positive 3. So to solve this, you set both factors equal to 0. And when I solve, add 6 to both sides. X equals 6. Subtract 3. X equals negative 3. Before I put these in as my final answer, I need to check to make sure that if I plug it into the parentheses that I have here, I don't get 0 or I don't get a negative number for any one of those parentheses beside log. So if I check 6, well, 6 minus 5 is 1. All right, well, that's good. 6 plus 2 is 8. That's good. All right, so 6 works. If I plug in negative 3, well, negative 3 minus 5 is negative 8. You can't have the log of a negative number. So automatically I have to drop out or cross out that negative 3. Negative 3 is not part of your solution. The only answer that you have is x equals 6. So remember to check. All right, check for numbers that are excluded from the domain is what it would say. All right. Another way to solve log equations is using this one-to-one property. So it kind of works like equating the bases. So if you notice here, you have a log base b in front of both the x and a y. It's an equation. So since they both have that log base b in front, that means that x and y must equal each other. And remember, x and y have to be greater than 0. It can't be 0, and it can't be any negative number. So to use this property, if you look at this example, first thing I need to do is I need to, just like before, I need to condense this left side. So to condense this, I'm going to write this as one logarithm. So this is ln. All right, I don't have to rewrite it as log base e. We already know that's log base e. So I'm going to write it as ln. Since there's a minus, this is x plus 3 over x equals natural log of 7. So since they both have this ln in front of both sides, I'm going to draw a fraction. That means that this fraction x plus 3 over x has to be equal to 7. So you drop off the ln and then you set what's beside it equal to each other. And then you solve. So to solve this, I'm going to multiply both sides by x to get rid of the x in this denominator. So x plus 3 equals 7x. To get x by itself, I'm going to subtract x from both sides. So 3 equals 6x. And then to get x by itself, divide both sides by 6. So I get x equals 1 over 2. Again, just like before, you want to check to make sure that when you plug that x value into that parentheses, you don't get 0 and you don't get a negative number. All right, and so this checks out as my final answer.